Thank you. Thank you so much for having me presenting today. As he said, I'm going to talk about building systems at massive scale. And I wanted to start talking about what scale we are talking about. First of all, thinking about Canva. Who has used Canva in this room? So Canva has a mission to empower the world to design. It's an Australian unicorn, the only profitable unicorn from day one, and has a massive scale. So Canva has been adding about 10 to 50 million users per year in the last few years. You can see all the graphs are spiking. The traffic is phenomenal. And how do you design systems that work at that scale? But sometimes it's not just for growth that just happens. Sometimes you need to face growth that is exponential by nature. This is a graph from when the pandemic started, and everybody started to work from home. And then Slack had to scale the system so they can work for millions and millions and millions of people that suddenly went home and started to use their systems. Oh, come on, you can do it. Hi, I'm Javier Turegano, and I just returned to Spain from Australia, where I lived the last 15 years, and I work at companies like Canva, Slack, and Aria Group that hosts realestate.com.au. I was director of engineering there and helped these companies to build systems that are adaptive for that. But my talk today will be trying to distill some of those lessons learned there for systems that work at all scales, because we all have the same problems that Canva and Slack may have. With my return to Spain, I'm working on my own and doing some consulting and coaching, but I also run boot camps for engineering managers and staff engineers. And you can join us. The next editions are over there and are happening here in Valencia as well as in Madrid. It's a little bit slow. What I'm going to talk about today is probably the agenda. You can take a look. I'm going to skip ahead. So let's start for chapter 1. Scaling 101. What are the basics of scaling? And I'm going to go very quick in there so you can get used to some of the icons I'm going to be using and some of the ways of working. This is a very simple architecture. If they tell you, pay me an architecture, you probably start at this point. You have a user, has a browser, goes to a service, and the service has a database. Those are icons you're going to see repeated all over my talk. But what are challenges that can happen when you're thinking about scaling your systems? A system can be affected by many different elements, right? You can have new customers. You can have a marketing event where like a lot of people are coming to your systems. For example, in Australia, we had one betting company where in one single day, they will make all the money that they make during the year. And that was the racing day. So they have to prepare the system so it works for that single day. New features and configuration changes can pose problems into your scalability. You can have malicious traffic, bots, and people trying to bring down your platform. Or you can be making changes on the underlying systems of your architecture, for example, changing the data format. There are many more things that can change the balance, and we need to be ready to scale when those things happen. So I try to picture that with more people coming into your systems on the right, or your left. And then that will put some pressure into your systems. In this case, the two elements that we had, so either your service or your backend is having problems because they're having more people than they expected, or your data store may have problems. What do we do? Well, with the evolution of the cloud and the usage of things like Kubernetes, we'll have two ways of scaling. Vertical scaling, so I buy a bigger computer, is the analogy there, or I pay more to my cloud provider to give me a more beefier instance, so more compute, more network, more memory, and problem solved. Or you can scale horizontally, incorporating a load balancer and then distributing the load between different instances of your service. Nothing revolutionary here. I think this is something that everybody is doing. The other problem is in your data store, and you can use probably similar similar strategies in there. You can buy a bigger database instance, or you can scale horizontally, adding read replicas or write replicas, or using a different technology for your storage. And you can combine both. Like at some point, probably you will find that the bottleneck is in the database or the data store. Sometimes the bottleneck will be in your compute layer. You can also evolve towards fit-for-purpose data stores that you can use. At some point, maybe a SQL database may not be the best way to store your information. You can use document databases and NoSQL databases like Dynamo or Mongo. You will store your blobs and your images and all of that in something similar to S3. And for example, you may need to search, and instead of using database for search, you will move to a search engine. All of that will allow you to kind of serve more traffic and to run faster. All of that comes without saying that you can also improve the efficiency of your service itself. Like sometimes we forget, we add more and more compute, and the way to scale is by making your service more efficient. So, for example, in this case, we may be using two different data stores for your space. You can also add a CDN in front of your service, and that will offload some of the load, will give you more performance, and potentially can protect you from some bad actors like robots and DDoS, etc. And that will remove some of the things that you need to serve from your service. Nothing revolutionary till here. So those are like some of the basic ways that you can scale your service. But what I really wanted to talk about is how do you think about that scale? What are some patterns that you can use for architecting when you think you're going to have significant growth? The first one is moving as much as you can of your services to asynchronous workloads. We think that everything needs to be served immediately, and that's not true for most cases. There are many cases where we could like just take the petition, I'll take the ticket, I'll give it to the kitchen, and the kitchen will take a while to cook the meal, and then it will come out later. But we don't question enough how many times do we need to do this. And I wanted to share two simple examples from Canva and Slack. For example, if you want to download a PDF of this presentation, exactly this was me downloading this presentation, it will take the petition, and then it will like fire it up to a queue, and then like some pool of workers will pick it up, make the presentation, and then we'll let you know when the presentation is ready. If we try to do that in a synchronous request, it may take longer than the time that your client may be waiting. Also, if you have many people trying to do the same thing, it could bring down your service. The other example comes from Slack, and it's a really interesting scaling problem that happened in early days of Slack, where I don't know if you've seen these very annoying ad channels, but imagine doing an ad channel in a channel that has hundreds of thousands of people. Imagine trying to serve that request at once. So now I need to like send those hundreds of thousands of messages at once, and that will require some time. So you can just take the petition. It's like, I want to send a message, like put it in a queue, and then have 100,000 messages delivered, and that will not bring your system down. That happened in the early days of Slack. It will come down when you had some organizations that were bigger than 100,000 people. The next step that you can take is to decompose your service into maybe smaller services. I'm going to avoid the word microservices, but like the pattern is very similar. You have different workloads, and the workloads will have different characteristics, and maybe you don't want to serve them all from the same pool of servers. And then you can divide it and use like a division by different domains. And then you can use a separate data store for each one of them. This is a technique, and this is how Canva was built inside and allowed them to scale to the size that I mentioned at the beginning. And then you can use for each one of your services a data store that fits the purpose of that service. As we said before, for example, if you have a search engine, maybe that will be using Elasticsearch or Solr instead of using an SQL or NoSQL database. And this is really powerful because then allows you to have different pools and different sizes on those pools. We talk about horizontal scaling and vertical scaling. If you only had one pool of services, then you need to increase that pool to whatever load you have. And you may be affected because some requests may take a long time to be served, and some of them may be very fast. This way you can decompose those and send them to different pools. I think one of the most powerful techniques I've seen, and that I don't think we practice it enough, is to degrade the experience when we're having problems. This will be a very simple example. We have a change of service, like the request comes to service X at Y, and then it sends it to service Z. Service Z is having trouble for some circumstances. Maybe it's getting a lot of load from other services. Maybe there's something that is not working well, and suddenly the whole thing goes down. Because we did not predict that service Z was going to have trouble ever, right? These things never happen. So when you're planning your services, you may be thinking that failure happens all the time, and then you need to plan for that. And an example that I really like about that was back at realestate.com.au. We had a service that will tell you the distance that a property will have to the nearest school. And then at the very beginning, if that service that calculates that distance and have all the information about the schools will go down, the whole page will go down. That makes absolutely no sense, right? But that used to happen. So you need to start to plan about how do you degrade the experience. In this case, it's very simple. You will not serve that information. You will have the property file with all the other information, but not serve that piece of information. That's not always possible, but it's something very important. And sometimes you can mask some errors. For example, at Slack, we had this thing where you try to send a message, and it will retry multiple times before failing completely, and that will hold that message for a while. And that has saved many times to have the feeling for the user that the service was completely down. On top of that, you can practice for this. It's not only a whiteboard exercise to think about how these things fail. The way that we discovered that the school service will have problems if it was degraded was because we brought it down in one of the dev environments, and then we saw what was the result. You can practice chaos engineering, and there's lots of literature about it, by turning off one of the dependencies. You can make the dependency slow, simulating that there's latency coming from that service, or you could, for example, introduce some latencies in the network. And all of that will give you some information about how the service will perform under circumstances that are not the ones that you planned initially. But this is probably a no-brainer. I don't think that you need to talk a lot about this, but probably you should invest in your observability. We all hate when you go and get paged at 2 a.m., you need to wake up, and then just to find out that you don't have the right metrics, that you don't have the right traces. And it's very powerful when you have your observability done right, and you get all the information from the request coming to the backend services, and you can identify where the problems in your architecture may lay. The other thing that has saved us many, many times is to invest in your deployment process, and to make a deployment process that is not black and white. It's not like I had version 1 and now I'm on version 2. Both at Canva and Slack, we will have a progressive deployment process that will probably go and deploy first into a canary, that being a very, very small server that will take a very, very small percentage of traffic. And then you can compare, using your observability, the characteristics of how that service is performing, and make a decision if you want to progress on the deployment. Then you go and deploy to 25% of your fleet, and then you keep checking that observability. And you can automate that. So if there is a problem, for example, as we're seeing here, we're deploying B2 on the green side. We hit 75% of the fleet, and suddenly you find that some of the metrics are not right, and you decide to roll back or roll forward, depending on what is your practice. And that has caused so many errors before. 100% of the services will, 100% of the customers will notice, and we were able to kind of roll it back before it was a complete outage. The other way that you can do that is a technique called dog fooding, which means that you will eat your own food before serving it to other customers, right? So, for example, both at Canva and Slack, we will have a different instance of the whole service where the new releases will be coming first. So employees will be trying all these new features, and they will be trying all these new changes that you are introducing before they will go live to your customers. So in this case, we will first we'll serve version 2 to our employees, and then we will serve version 2 when we are sure it works for everybody out to the rest of the population. You can do something similar, but not with the whole service. You can use feature flags to obfuscate or not serve some features to your customers. And I've seen some companies will use the feature flags to maybe serve first some of the features to a network of champions or more advanced users that will probably tolerate a little bit more of trying something new and then get feedback from them before you roll it out completely to everybody. I think there's another practice that is very useful, which is like trying to predict how your system is going to break. You can run production readiness reviews when you are like making big changes to your systems and services, and like work together with your SRE team. You have one, or with your colleagues to try to anticipate what are the ways that a system will break. And for that, we have this pattern that is called pre-mortems. Like most people are used to post-mortems, which is like what you do to analyze the system once the system was dead, right? And that's like, you can do things to prevent for more systems dying, but then you cannot try to anticipate what's going to happen. And this exercise is very useful to try to anticipate that. Let's imagine like we roll this out, we're going to bring this new feature. How is it going to break? How are things going to break when we release it into production? And then trying to kind of simulate that if you can and try to avoid it. But when you are growing massively, you uncover new challenges that maybe you haven't seen before. So we're going to explore some of those challenges next. One of them is the imbalance of a scale problem. And that happens when we follow all the practices that I talk about, and then we decompose our service into smaller services, and now we are able to kind of scale those services independently. But what happens when one of your services suddenly gets a lot of load and starts to grow very quickly? And I'll talk about an example from Slack where we added 1,000 servers at once to one of the pools because we were not able to manage the load. What happens to the services that are downstream? Even if it is in the case that we talk about using a queue and using asynchronous workers, if you, for example, put a lot of work in that queue, then the graphs will go up, and then suddenly your workers will say, "Ooh, there's a lot of work. We need to get this work done." And then like suddenly we'll add a lot of compute to make all that happen. But then the poor service Y over there that was not prepared for this scale will come down. So you need to find ways that you can tackle this imbalance of scale. If not, you will get, come on internet, you can go faster. You will get this, which is the thundering herd, and things will go slow. I practiced this and it worked. There we go, they're moving. So you can imagine that that's what happened when we added all those servers and they started to make requests to our poor service downstream. And that happened at Canva recently when I was working there. We had an incident where Cloudflare was not able to serve one of the items that are part of the object panel, and that object panel is fundamental for how Canva works. So the element that they could not serve was the prerequisite to start loading the page. So suddenly, across the wall, thousands and thousands of customers, millions of customers could not load the page and like would be waiting. You know, the browser will like wait, and retry, and more browsers were like queuing to kind of get that information, and suddenly Cloudflare made that element available, and that would have not been a problem. The problem is as soon as you get that piece of JavaScript, suddenly you can load another 100 items that are required. So every one of those million browsers that were waiting requested like the other 100 elements at once. And that melted our gateway layer and completely brought down Canva. And like the interesting part is that at that point, and that's very common, when your service goes hard down, there's a problem on bringing it back online. Because you are receiving all these requests and all of these retries of people trying to come back, and you are hard down. So how do you come up if you like keep throwing things at you when you are on the ground? In this particular case, we had some tools in our toolkit that allows us to block the traffic per country. So we will decide that we'll start with this country. Once we have enough systems and everything is working for country X, then we will add another country and then a full geography until we were able to bring back the entire of Canva. I think as you scale and you start to decompose your services, one of the practices that becomes more and more important is traffic management. Because your services talk between each other, and then some of the practices that may seem to be harmless and useful at some point, they may not be so much. For example, if you do time-offs and your service is requesting something, and then you schedule a retry, and then all the services retry at the same time, we will have that thundering herd problem that I talked about before. So you will need to think about how you're going to plan those retries. You can use things like jitter, which is adding more and more time and not the same amount to the retry, so all the retries don't happen at the same time, or you can apply back pressure from your services. One of the techniques that are very, very effective with this type of problems is load sharing. And the concept is very simple. Your service will be able to kind of produce some throughput, and we have two elements in here. As we go to the right, we are trying to get more requests done, and on the vertical axis, we have the ones that are served correctly, that are served inside of our SLA, or they are correctly served. So we will be increasing, and our service will be able to kind of produce that good put. And then as we keep asking more for it, there will be a point where they're not able to serve it. And as we add more and more and more requests to it, it will degrade until it's completely unusable. The idea with load sharing is that at some point we will stop serving those requests. The blue line is showing how we will do that. We know that our systems can get 100 RPMs, or I think it's 200 in this sample. When we hit that limit, we will stop dropping requests. You are asking me to do something, but I'm not going to do it because I know if I go over this limit, then I will not be able to serve correctly. At some point, what shows this graph is very interesting, is that even if you are dropping requests, the cost of dropping requests, if you keep increasing the throughput and the number of requests that are coming into your service, may bring down your service, because the cost of doing that, I'm not able to serve this request, will be so high that then you will go down eventually. There are other more advanced traffic management techniques that you can add. For example, you could do priority services or service quotas, where you will decide this is a very important service, and we need to make sure that it's getting the best attention, and we'll have it in the priority queue. So we will be serving much more throughput for that service than maybe for the print service at Canva that doesn't have so many requests. And that will allow to protect from those kind of massive scales that happen in a service that is maybe not so important. You could do it in a more complex way, which will be give a different priority to different requests. And this starts to become very interesting. For example, could you prioritize traffic that is coming from paid customers? For example, Canva has a paid tier and a non-paid tier. You could maybe decide that you want to serve those requests first, or maybe you want to serve the requests that are coming from synchronous requests first, because you know the asynchronous one could take a little bit longer. So you could prioritize even despite of what service the request is coming from, and decide to drop some of those requests. In that graph, it's so the green ones have priority, the other ones don't, so I'm able to drop the ones that I don't care too much about. And now with the wall of LLMs and adding AI to the picture, we are changing the characteristics of how the systems work. We were very used to have APIs and HTTP requests between our services, but now we are moving to a wall of streaming. If you are incorporating an LLM to your system, well, your APIs that are maybe calling to that may take a little bit longer to get those responses, and we need to get sure that we get the timings right and the scaling right when we are incorporating LLMs in these workflows. There's some usual aspects of tools that you can use to configure your traffic management. You can use Envoy as a proxy. You can use gRPC between your services, or you could build the whole service mesh between them using Istio, depending on your needs. But what do we do when things go wrong? I think this is probably one of my favorite war stories of my time at Slack, and that was on January 4th. We're still part of the recovery from the pandemic. We've just seen the graph of number of teams created. It was massive. And then we went, everybody on Slack went on holiday for the Christmas period, and we're like, we have the systems ready, and we're in a good position for when things come back. But then New Year comes back, and everybody comes back to work, and there's not enough capacity at Slack to serve that. And that's at the point where we're like, well, we have auto-scaling, so there will be no problem, right? We add more capacity. The problem was the amount of capacity that we really needed to serve those and calculated by the system was that we needed 1,000 more servers than what we had at that point in time. That created one of those problems that I talked about before. We had a service that will tell you when a server comes online, what is your role in life? I'm a web server, I'm doing this or that. The 1,000 new servers overwhelmed that provisioning service and brought it down. So there's 1,000 zombie servers waiting in there saying I don't know who am I and what am I doing here. And that started to kind of create more pressure on the existing servers that were there until the whole system collapsed. And again, bringing back from that is a very complex issue. But there's a really good blog post in the Slack engineering blog that talks about what was happening behind the scenes at that point in time. And I was one of the hundreds of employees trying to bring back Slack to life. And we were all coordinating and trying to coordinate. And a lot of people ask me this: what do you do at Slack when Slack is down when you're trying to coordinate? Well, the first part I'll give you a clue before, which is we have our own dog food here. So it's separate from the main Slack, so we will be able to run. But sometimes both of them go completely down. And there were at least 2 different mechanisms that were already put in place, so we all can coordinate the response, because you could not coordinate that response if you cannot talk. So we'll have a always on Zoom call that everybody will have bookmark, and that you can go on that. But a lot of services are all deployed in USS 1, and sometimes the Slack will go down with other services like Zoom. So we will have a Google chat ready, and there was an email as last resort of okay, this email will come up to everybody with new instructions if our 2 mechanisms of backup will go down at the same time. And then there's the usual, what do we do with this? We've had this incident, we had all these problems. How do we learn from it? How do we make this a more powerful system? And from some of those postmortem are some of the ideas that I extracted for this talk. But I think as a technology community, we probably will have a really good opportunity to share some of those lessons and learn from each other on how we fail at scale and how we build more resilient systems. So if you have a problem, maybe you can publish that and share it with the rest of the world so we can all learn together. And that's my talk. Now I'm open for questions.
Any question?
Podéis preguntar en español si queréis también.
I will be in English. Thank you. Thank you for your talk. I have a question. How do you scale? You have after-scaling logic, and what do you use as metrics for it? Do you use some business metrics, CPU, like memory, or FPS? Because, for example, our experience, it's quite hard to define those metrics to really be after-scalable when the things are going down. Thank you.
It will be a combination. It's not a single metric, and that has been the problem sometimes. For example, for some systems that are asynchronous, they will use the depth of the queue to know how much work is coming into that space, and maybe the latency of that queue. For systems that are synchronous, maybe you will use some of the system metrics like CPU, etc., to kind of guide your scaling. Some of the cool things that we did at Slack, for example, was to use predictive scaling as well. So we will complement the auto-scaling with what did we see last week, what did we see last month during this period of time, and that will allow us to pre-scale before that load is even coming to the system. But it will be a combination. It depends on what the system is doing, right? And that's the power of being able to decompose those services, because at that point you are able to guide your scaling policies based on different metrics. No worries.
Hello, thank you for the great presentation. I have a question. How would you deal with the customers when the server is down?
That's a really good question. At both companies, we'll have like a really good customer success team, and they will like bring notifications to those teams. Both of the services will like target the enterprise, so they will have their account managers. They will come in. Both of them will notify everybody using a status site. So we'll have a completely separate place where we'll host the status of the service. And as we are trying to recover the service, there will be someone that is on duty to update the status site and like provide updates on how. What are we seeing? Do we think that the service is going to recover soon or not? And some of those will be like sent directly to certain customers that have asked to get real-time updates on how things are going. You can always go there and find out what's happening. I think the very interesting part sometimes happens in the after, and we had to kind of, for example, in the case of Slack, big companies that rely on Slack when the system was down, they were very worried about the stability of the system, right? And they're like, we cannot allow this to happen. Like, what are you going to do to improve that? And many times we will have to go and like talk to the VPs and to the CTOs of those companies and tell them about what was the plan. And I think that's the power of those postmortems, to kind of like collect all the information about how you're building the plan, and you're sharing the kind of root cause analysis with them about what things happen in your system and why did that happen. And like, as you know, like incidents normally don't happen because one reason, and it's normally like a combination of contributing factors that brought that system. Some of them are like process related, some of them are system related, and some of them are people related, right? So you will like combine all of that and then present it back to your customers. You can degrade your system. Sometimes you could avoid having the feeling, and that happens all the time. I think from like in these big companies, there will be some problems that are very noticeable and that everybody will be seeing how they're happening. And there will be some of the problems that are completely invisible. Like there will be incidents happening all the time in the background. There's people fixing things that you never see. But if the system is clever enough or like has been architected right, maybe things are broken and you don't notice about it.
Hello, thank you for the talk. Yeah, this maybe is a bit off. But I don't know if you know the cell-based architecture. I think that one of the objectives of that is to minimize the radial blast of microservices falling down. So I don't know if you think that will be a solution for that kind of recovery stage.
So the idea of cell-based architectures will be like that you can encapsulate all the things that you need into a single cell that is able to serve your service, and then you will have multiple of those. So if one cell goes down, the service will continue. At Slack, we implemented something similar at the AC level, so an availability zone in Amazon, or like a data center or set of data centers, and that will encapsulate everything that needs to serve the service. In that case, like you could lose one data center, you could do cellular at like the region level, and that's much more complex. I think it can work, but it has a lot of complexity added to the system. And sometimes when you are adding complexity, then you could find yourself in points where you are actually having more incidents because of that added complexity. So you really need to balance out when you decide to make something like that happen. But I will be thinking from the beginning, if you're building a new service, to think about what type of failures I want to be able to sustain, and like based on your SLAs and like what you want to offer to your customers, what are the measures that I put in place, and that's one that you potentially could use.
I'd be curious what role AI is playing today for observing these systems. Like if you, in bigger organizations, if they're already used for actively, quickly understanding issues when they pop up.
Yes, I have in my mind there was a talk at the SRECon Singapore, like maybe 6 or 7 years ago from Microsoft. They were talking how they were starting back then to incorporate AI into their incident response processes, where they will feed the AI with all the information about how the service is performing, and they will have historic data about different incidents that have happened. And then the AI will be able to kind of identify that, and it will give you a score about how confident am I that I can solve this problem without waking up an engineer. And I think that's like a direction that I really like, and I think like it will be great to see more. And I really like the algorithm that they propose, which is like if the AI has a really high confidence, we've seen this incident happening many times, and the actions are not risky, we will take them. Like the AI will independently take those actions. If the score is like medium risk, they will wake up the engineer, and then they will give some guidance on like, we think this is what's happening. We propose this route, but we don't have confidence enough to do it on ourselves. And then it was like, below some threshold, it will like get out of the way, just wake up the engineer and let them deal with it. And I think like that way of like shielding some of the noise, I didn't have something so advanced in either company, to be honest, at the time I was there. But I think there's a lot of power on analyzing metrics, analyzing trends, and like being able to kind of feed that information so it can bring it live to the people that are, for example, responding to an incident, or even to being able to kind of shape the system in a way that works well. Like talking about, for example, predictive scaling, I think there are many things that can be done by data analysis to kind of think about how your system should behave when a problem is happening. Think about that imbalance of power that we're talking about in some areas where like you're growing one pool. Should we be able to kind of preactively start to like bring up other pools? And there are many things that you could do to kind of inject intelligence into the systems using AI. But again, the complexity factor, right? As you are adding more complexity into your system, there may be cases where you are doomed because of that complexity and making the situation worse rather than better.
Hello, thank you for the talk.
No worries.
I have deep technical question about prioritization of traffic and like in general terms, how it's done on technical side, because just prioritizing traffic sounds like a little dangerous and complex.
Yeah. I think like where the parts where we explore this area were mainly about like adding tags into your traffic. For example, what service is like requesting this information, and then leaving it to the service that is receiving the request to make the decision about do I want to serve this or not, right? That will be the basic of some of the prioritization that I talk about. You could tag with many other pieces of information. Is it live synchronous traffic that I need to serve or not? And then like delegate it back to the system down there. But I'm with you, like talking again about adding more complexity to the system can make it more fragile. I think that's something important as you like try to make these more efficient. You may be making it less efficient. So it's always like a balance between those parts, and adding many dimensions to prioritize that traffic will make that every service needs to do a lot of work even before doing whatever is done in there. But like tools like Envoy and some of the tools will have baking mechanisms to kind of do prioritization based on those type of tags. So we'll probably be relying on those to kind of like start trying something like that. But yeah, it's not an easy task.
So it's like a tag on the load balancer.
Tag on the HTTP request.
Okay.
Yeah.
Thank you.
Yeah, no worries. That was a much shorter answer to to the question.
Hi, Javier. Thank you for the talk. I have a question. You mentioned that you had activities to anticipate the problems with postmortems, to avoid postmortems. Can you share, please, which kind of tools or systems did you use to do that?
So for a pre-mortem, it will be people. So mostly will be like we get together in a room and we know like we are launching a new feature and we know that something is going to happen, and then we'll like all get together and discuss about like how do you see this breaking? How do you think about that? Have you noticed that we're very close to the limit in this service? And that happened a lot. Like for example, Canva has 2 big events a year, and there will be big launches of all the releases on that single event. So there are many things that are coming out. So these kind of like meetings, trying to anticipate those problems, have saved a lot of trouble down the line. You could use all the data that you have about how the service has performed. You can use all the information about your previous postmortems as well to fit into that information. But I think like maybe chaos engineering and like practicing the act of actively trying to get the system to behave in a weird way is also a form of pre-mortem, right? Like you're trying to anticipate ways that the system is not going to work, and then you're trying to fix it before it actually happens.
Any more questions?
Hi, Javier. So in one of the first charts, I don't remember if it was Canva or Slack, but it was about the pandemic and the exponential growth you had. How did you handle that, especially the auto-scaling?
Well, you saw the incident that happened
Yeah.
later on. That was like a year later after that graph. So the graph, sorry about all the scrolling.
one, yeah.
This graph talks about the number of teams created, and it was posted by one of the Slack founders talking about how many teams were created. Like we had a very steady line on like how many new, and think about it as new Slack instances created. Like for example, the Valencia Tech Hub instance will be one of those, and these are like the number of new teams that were created. So there were like many teams and many people that suddenly are like, wow, well, we've been working in the office, we're all together, and now we need to kind of all work remotely. What do we do? Let's create a Slack instance, right? And some of the architecture was quite solid and was able to absorb to a point of that growth, and we were like looking at different systems and how they behave and modify them. But the architecture of Slack was heavily influenced by the way that Facebook was created. So some of the Facebook engineers joined Slack in the early days, and like they shaped it. So some of the fundamentals of growth were already with the architecture. So it was already built with some growth in mind, and some of the components will like work for more load than what we saw at that point. But some of them will not. So we'll have to kind of on the fly try to kind of start fixing. And you know how this is like. The system is operating, the system is working, and you need to bring things that will make it more resilient at the same time that it needs to be working. So you cannot stop. In these companies, there is no maintenance window that, okay, this weekend we will fix all of that. You need to perform all the changes live, and that creates all the risks, because a lot of the breakage and a lot of the incidents that you see in the industry are because a change that modified the system that the system was not able to cope with it, right? So we'll be performing that. I cannot pinpoint one single thing that we did, and if that's what you were looking for, like we increased a lot of the compute that everything had, but again, like the architecture used some of the principles I talk about, moving a lot of the work into asynchronously. We've been doing this initiative where we were moving from much smaller teams. Like we're in early days of Slack, we will have much smaller teams, like maybe 1,000 people, 5,000 people, but we were signing up enterprise customers that were much bigger. So before I joined, they signed up IBM, and that was like 300 or 500,000 users. And then recently before that, we signed up Amazon, and that was like 700,000 users. So like, we've done a lot of work to load test and like to try the platform so it can work for a dimension, which is many more people in a single team. This is a different problem, right? This is adding many more teams and many more people. And I think like one of the difference in how the two systems that I talk about work, like Canva has probably more users today that Slack had, but Slack has much more usage. Like if you think about how developers and people are working, they're constantly pumping messages into the platform. It's non-stop, but like because it's a global platform, it's on all the time. And Canva has a different pattern. Some of the use cases are much heavier, like generating videos now, generating images. They're like different load characteristics. But yeah, there were many things that we changed after that. One of the things that we tried back to cellular architecture after some of the incidents was to try to minimize the impact of those changes. So you introduce a change, and it should not break the whole system. It could maybe damage a cell, but not damage the whole thing. And like things like the progressive rollouts help with that. But like you could even make it more powerful by doing the rollout cell by cell rather than just broad percentage base. So some of the things that we tried.
Last question, please.
First, thank you for your talk. And my question is, do you have any tips or recommendations to really get better at system design when you cannot really experience this? Because I think it's hard to, when you are at your home, rising, like it's hard to experience these things. And I feel that's the way you learn, but I'm not sure if you have any tips or things to really get better without having to be in Slack, for example.
That's a really good question. I think that nowadays you can practice a lot in a home lab, and I think like some of the practices that we talk about and some of the problems that I described, you could simulate in a lab. And I think that the scale of like having hundreds of thousands or millions of users is difficult to simulate, but I think like some of the problems you could try to build an architecture at home and then try to add traffic. You could do chaos engineering in your architecture. You have like one for work. You can start by thinking about how the system will break, introduce failure, and see how it behaves. And I think all of those techniques, which is like what I try to kind of bring to this talk, is that you don't need to be a Canva or Slack to think about some of these techniques to maybe help you with the way that you architect and you build things. And I think you can simulate some of that with the kind of emulation that we have today.
Okay, thank you, Javier.
No worries.
So just a reminder before we go to the snack that is ready. Just a reminder that this afternoon between 6:30 and 8:30 we will have an after-party event. If you want to come, please find someone from the organization because we have a limited amount of people. So just that. Thank you.